Everybody, I'm really happy to see that there are so many people who are willing to get up early in the morning to see me talk or listen to me talk. For those of you around the back, there are a bunch of seats down here in front. You don't have to stand in the back or sit on the side if you don't want to. But anyway, so I'm going to be talking about hardening the C++ standard library implementation LLVM. I'm going to discuss a variety of techniques, some of which I suspect most of the people in this room will say, well, duh, of course you do that. Others, I hope, will be new to you. Okay, little bit about me. I work for Qualcomm in San Diego. I have been working on LLVM off and on for about 8 years, and on libc++ for about the last 6. I am the code owner, which is LLVM speak for the person responsible for libc++. My other job is that I sit on the standards committee where I'm the chairman of the library working group. Just for your information, the library working group is the people who are responsible for the wording of the library portions of the standard, so say the back 1,000 pages of the standard. Unsurprisingly, the people who sit in that group are mostly people who implement standard libraries. They're all very concerned, or we're all very concerned about that the wording is precise, that, for example, Jonathan Wakely, who does libstud C++, and I don't implement from the same words and get code that, get calls that do different things. That would be confusing to users. But anyway, I have contact information here. If you have questions for me, send me email, find me on Slack, on IRC. I have a Twitter account, but I'm not on it very much anymore, so I didn't put it up here. Okay. So, what is libc++? libc++ is a sub-project of LLVM. It is a standard library implementation. It contains things like vector and shared pointer and sort and so on. And yeah, there are not very many standard library implementations out there in the world. I can think of 4 off the top of my head. There's the one that Microsoft ships. There's the one that GCC ships. There's libc++. And then there is one company called Dinkumware ships that they sell commercially. And there are various partial, more or less complete versions, I'm sure living inside various corporate code bases that I don't have any insight into because I've never seen them. Okay, so part of this talk. Why do we care about hardening the standard library? I mean, besides just, pride of workmanship, which is a not insignificant motivation. So everybody who writes C++, except if you're writing on like very tiny machines, bare metal kind of things, you end up in some way depending on the standard library. Okay, it's pretty much the bottom of your list of dependencies. It's that if you use some other library, it probably uses a standard library. So it's kind of really important that the standard library be complete, correct, and reasonably performant. I mean, if the standard library is too inefficient at doing something, people are going to want to write their own, and then we get implementation divergence, and frankly, that's a waste of other people's time. I would be sad if you felt the need to rewrite your own vector, say, just because you didn't like the one in libc++, because you've got better things to do with your time. You want to work on solving the problems that are interesting to you. You want to use vector to do things. Okay, so some of the techniques we use. We have a test suite. We talk about warnings that the various compilers we use we'll talk about. We talk about precondition checking, static analysis, dynamics analysis, and last but not least, fuzzing, and a couple other things along the way. By the way, if you have any questions at any time, just put your hand up and ask. I'll try to answer them immediately. Occasionally I will say, that's a really good question, hang on to it, I have a slide coming up about it. But in general, I'll try to answer them immediately. No need to try to remember it till the end of the talk. Okay, any questions before I dive into these? Okay. Okay, test suite. Well, okay, this is the first of the duh moments. I mean, this is 2018. People don't make big software projects, I hope, without having a fairly hefty test suite. And we have one of those. This consumes a not insignificant fraction of mine and the other people who work on libc++ on our time. On the other hand, this is a good description. It's a good start. If the test suite was twice as big, I'd be happier. It's more, you know, we have an unusual situation here. Is we have people standing at the back. There are seats down here in front, by the way, if you want. If you want to stand, that's fine. But anyway, we have an unusual situation here that we have a written spec with things documented, preconditions and complexity guarantees and so on and so forth. And so the first cut of writing a test for libc++ is you read that portion of the standard that talks about, oh, I don't know, vector front, say, and you say, what does it do? What does it have to do? What are its preconditions, and so on. But then you start getting creative and you try to figure out, you know, what are all the edge cases and so on like that. But writing tests is not always straightforward, but we think we do a good job of this. We also have a bot that generates code coverage based on the tests. And this is one of my low-level ongoing tasks, is whenever I'm avoiding other work for some reason or other, I go look at the bot that does the code coverage and say, well, what part of the code base isn't getting covered, and how can I write a test that exercises that? This is a really good way, by the way, if you're interested in doing libc++ development, or you're interested in seeing what it's like, this is a really good way to get started. You know, pick some part of libc++ that interests you, look at the tests, say, oh, I can make those better, and trust me, you can. And then contact me and say, hey, I have some better tests. And I'll say, that's great, but that's not quite how we lay out our tests. They need to be done like this, and thank you very much. When I put these slides up on, you know, and after this talk, I'll make sure the link to the code coverage bot is in there. But or just, you know, look through there and say, oh, look, there's something that interests me and it doesn't seem to be tested near as well as we might hope. So I want to add some tests for that. So yeah, we're always looking for people to help. The libc++ team is very small, and there's an immense amount of work to be done. Okay, anyway, we have a test suite. It's about 7,000 tests these days. 15,000 would be better. Okay, warning eradication. Warnings, compilers warn about all sorts of things. Some of them are good, some of them are less good. But we have to live in other people's code base. libc++ gets included into the amazing number of different programs. The headers do. Some people don't care at all about warnings. Some people compile like this. All the warnings, all the extra warnings, and oh yeah, make the warnings, all the warnings errors. And they get grumpy if code that they don't control throws warnings which causes their builds to break. And so we have to support all these people. And so partially what this means that we have to drive the number of errors or the number of warnings to 0. So we build with this kind of configuration. We test with this kind of configuration all the time. Occasionally we will suppress errors from some compilers because, much as it pains me to say it, compilers are not always perfect. Yeah, I know, David is shocked. I've just completely shattered his worldview right there. libc++ is not always perfect either. Sorry. In the run-up to the 6.0 release, we had a little back and forth discussion. I don't know how many of you people or follow the mailing lists or followed the discussion about -w tautological compare. Did anybody follow that discussion? I see a few people nodding. somebody added a new set of warnings that looked and warned on comparisons that were, always true or always false or so on. And that was great, but there was a general case of a general pattern that it went off on that I really believe it shouldn't have. And that the way to describe it is you have some calculation that you do as a long because you're worried about overflow. You do some calculation as a long, and then when you're done and you have the resultant value as a long, you say, if the value is less than numeric limits min of int, numeric limits int of min, or greater than numeric limits int max, generate an error. Otherwise, convert that long to a short or to an int. You've done the test. You know you can do that shortening without a loss of data because you've actually done the tests. Fine. But we started getting errors, or we got warnings which reported as errors on various targets in libc++. Not all the targets, just some of the targets. And it turned out these were targets where int and long were the same size. And that the warnings were comparing a long to numeric limits max int was always true. Or always false, depending on how you did the test. And we went back and forth for a while because this, people suggested, oh, you could just test to see if, double underscore size int is equal to double underscore size long. And I threw up my hands and said, no, that's not how we do things here. And that just helps for int and long. We don't want to talk about the difference between long and long, or int and short, or all these cases. And so basically at the last minute, the test was pulled, the warning was put in a separate warning group. It's not in here, and it just needs some more thought. The problem is that you need to look at this at a higher level than just a particular instantiation of some template code. You need to notice that even though these two things are the same size and maybe even have the same representation, they are two different types. And so this is one of these cases where we went back and forth about warnings a lot. But anyway, needless to say, we try not to suppress warnings whenever we can. Some compilers are really, really aggressive about warnings. It's like the Microsoft compiler when you have an int and you assign it to a short, and it's like, I'm looking at it right here, it's 10. And it says, no, you might lose some data. Anyway, okay, so precondition checking. Pretty much every call in the standard library, if you're a masochist and you like reading the standard, has a thing that says requires, either right there at the call or in front matter that says this applies to all these calls. Requires is how we say this is a precondition. Requires is a condition that we put upon the caller. It's not something that the library has to do, it's something that the caller has to do. Some of these preconditions are really easy to check. Some of them are harder to check. Either they require cleverness or they require a fair amount of computation. Some of them can't be checked at all. And I have examples of all those. Okay, libc++ has a macro called underscore libcpp assert. By the way, pretty much all the macros that libc++ defines start out underscore capital libcpp underscore. Easy way to tell where that macro came from. But anyway, libcpp assert, which is defined to expand to nothing. It does nothing. You can define that yourself in your code to do something else. I just want to point out as an aside, one of the things that people like to do occasionally is define libcpp assert to throw something. Recent advancements in Clang have made that a non-starter because we'd call libcpp assert in functions that are marked no accept. And now Clang will check that at compile time and fail to compile. It says, you're throwing from a function marked no accept. It used to be that if you did that, it was straight to terminate. but that's at runtime, and now it's at compile time. Anyway, but in general, from the standards point of view, calling a function without satisfying the preconditions is undefined behavior, and you have pretty much no guarantees what's going to happen. So let's look at some of these. Okay, vector front, right? We have a vector of t. You want to say, give me a reference to the first object in the vector. The precondition is the vector's not empty. You have to have a first element to return a reference to. Okay, this is easy to check, right? If you look at the source for vector, it says libc assert not empty, and a message. And you can enable these, no problem. And if you call, vector front on an empty vector, you'll get whatever behavior libc this thing is defined to do. Different one. Sort takes iterator first, iterator last, and a comparison predicate. The requirement is comp shall induce a strict weak ordering on the values that you're trying to sort. Okay, what is a strict weak ordering? The strict weak ordering requires that for every pair of values in here, first for every value in here that comp AA is false, and that at most one of comp AB and comp BA shall be true. It's okay if they're both false. It's okay if one is true and one is false. That's kind of what you expect, because the model here for comp is less than. That's an easy mental model. You have less, A can be less than B can be less than A. It's really bad if A is less than B and B is less than A. It's also really, it's okay if A is not less than B and B is not less than A, because that kind of implies that they're equivalent. And the third one is transitivity. If A is less than B and B is less than C, then A had better be less than C. Okay, as an aside, less than on floating point does not actually satisfy this if you have nans. If you don't have nans in your data, floating point is less than is just fine. But anyway, you can check this. This is eminently checkable. You run through every value in the sequence and make sure it's irreflexive. You run through every pair of values and make sure that it all makes sense. You run through every triplet of values and make sure that the transitivity holds. Okay, but that's n cubed, maybe n squared if you're really clever. I don't know. This is an n log n operation, hopefully. Do you really want to, do you want to quadruple your running time? You do want to change it to an n cubed operation for validation? That's not a decision that the library is going to make. You can wrap this and do your own checking if you want, but we're not going to do it because people depend on, we'll go all the way back here. What was the word I used? Performant. People, if we did all this precondition checking in sort, nobody would use sort. Everybody'd write their own. So we don't really do anything here. If somebody wants to contribute to libc++ some really clever way of checking this precondition, I'll happily take it, but I sure haven't found one. Okay, third one. Here is distance. Right? You pass it a pair of iterators. It has a precondition. Precondition is last shall be reachable from first. Now, if these iterators are pointers, that's easy. You can always get from one pointer to another. But if there's something more complicated, something, how do you test this? How do you test if this is true? You start the first iterator, you increment it, and you go till you reach last. But if that succeeds, that tells you that it is reachable from first. And if you go for a while and you don't get to last, well, maybe you just haven't gone far enough. There's no way of knowing. By the way, that's what distance does, is it tells you how far it is from first to last. But in general, yeah, you can't check this at runtime. And so we don't even try. So to sum up, we do the easy stuff. We know where the expensive stuff is. And some of them we just don't try. OK, next tool, static analysis. I've tried various static analysis tools. I'm really excited about the talk yesterday about iterator-based static analysis testing. And then there's another talk today about improving the Clang static analyzer. But I haven't found anything that really makes me, oh yeah, this is really good. This is giving me a lot of bang for my buck. Well, and by buck I mean time. I'd like to do more static analysis. We don't do near enough. But the current state is that they tend to be very noisy with lots of false positives that require you to sit down and think about. It says, oh, there could be a bug here. And you, oh, can you think about it? Oh, can you think about it? No, I don't think there's something there. Or maybe there is. If somebody knows good static analysis tools that are available on my budget, i.e. pretty much free, I would love to hear about them. Because this seems like a hole in our infrastructure. Then again, it's a hard problem. Our keynote yesterday, they were talking about little tiny programs. And there you are. OK, dynamic analysis. Dynamic analysis on the end is a fairly mature, at least in LLVM, is fairly mature. libc++ jumped on the sanitizer bandwagon fairly early. Here's a couple of blog posts, LLVM blog posts that I wrote. Note the date, 2013. We found several bugs. We found a few bugs. Found bugs that would have hurt users in the field. Found a couple bugs that we would never have found otherwise. If you read this address sanitizer one, there's an allusion to a problem that libc++ had in its streaming, its StirStream implementation, where when you start it up internally, the StirStream would allocate a buffer to hold its contents. But the buffer would start out as 0 bytes long because you have no bytes. And then when you wrote to it, it would resize it. But there was a case where it would write 1 byte to that buffer and then resize it. Clearly, this is wrong. Clearly, this could lead to heap corruption. At this time in 2013, almost all the places where libc++ was being used was on macOS, and the default allocator on macOS always rounded your allocations up to a multiple of 16 bytes. And so even if you asked for 0 bytes, you got 16. And so this was a bug that would never manifest itself on macOS. There was no heap corruption, there was no heap overflow, except in a theoretical sense. So this is a bug that nobody would ever see until people started using libc++ on other platforms with other underlying allocators. But ASAN just pinged it out immediately. It's like, you have a logically 0 bytes in memory here, and you're writing 1 to it. And it was like, bing, and it was easy to find and easy to fix. libc++ also has ASAN integration for std vector, where they're very familiar how vector works. It allocates a block of memory and then fills it up, and there can be extra memory on the end that is not yet used. Well, in libc++, we tell address sanitizer that this part of this buffer is used and this part of the buffer is not used, so that if you read or write off the end of the vector, even if it's still inside the block of memory that the vector is managing, then address sanitizer will go off. And will tell you, you've read off the end of the vector. This is great. How many people here use address sanitizer regularly? Just to see hands. Oh, good. The rest of you, you're missing a bet. This is a great way to find bugs. You build things with address sanitizer, you run your tests, and you just watch for failures. And every single time, the beautiful thing about the sanitizers is that there are no false positives. Every time it goes off, there's a bug there. It's like, you've read off the end of this memory block. You've written outside this memory block. Anyway, I can't say enough about ASAN, because it has made my life so much easier. Also, yeah, we have bots that run our test suite under ASAN and UBSAN all the time, so that not only do we got to the point where we're ASAN clean, but we stay there. As a general point of software engineering, it's much easier to get to 0 bugs or to 0 failures, to 0 warnings when you build and so on. It's much easier to stay there than to get there. Anyway, this is an ongoing job, especially with the undefined behavior sanitizer, because Richard, who I don't see here, but these lights are bright, Richard, who's here at the conference, keeps adding new features to UBSAN, catching more kinds of undefined behavior. So every now and then it'll get a new, there'll be a new feature in UBSAN, and suddenly our bots will start failing. And we go, oh, there's more undefined behavior. Dang. Questions about this? Okay. Last topic, fuzzing. People familiar with fuzzing? Any show of hands? People familiar with profile-guided fuzzing? See more? A lot fewer hands. Okay. Anyway, libc++ is a really nice target for fuzzing because it has lots of entry points. The entry points are more or less independent. You tend to not need a lot of setup to do fuzzing. It's not like, say, something implementing a networking protocol where you have to step through a bunch of setup to get to the point you want to fuzz. You can just call sort or find or something like that without a lot of setup. So I did a bunch of fuzzing stuff with libfuzzer in Clang and found a few bugs. But then now we use OSS fuzz, and I want to talk about OSS fuzz because, as far as I'm concerned, OSS fuzz just rocks. And I want to thank Kostya and his team for setting this up. Kostya's not here. Anyway, OSS fuzz, link here, is a project that was set up by Google. And it's a fuzzing as a service for open source software. And basically what you do is you give them a link to your repo, directions on how to build your software, and then some glue code. So basically how you, after you build it, how do you fuzz this package that they built? And they pull it, and they build it, and they fuzz it on Google's compute engine. And you don't have to do anything. Every now and then, you get an email. It says, we found a bug. And this is really, really cool. Every now and then, you find a bug for some reason. Or, in an ideal world, okay, really? 4? Sorry. In an ideal world, you'd set this all up and nothing, from your point of view, nothing would happen at all. You wouldn't receive any notifications or anything because, right, we don't write software with bugs, right? None of us do. We're all professional. We know better than that. But no. If you have questions about this, feel free to catch me in the halls or somewhere this afternoon. By the way, this is also another great place to get involved with libc++ development. There's lots of entry points in libc++ that we don't fuzz yet. It's an interesting way to learn about the standard library, learn about how things are organized, learn about fuzzing. So I have an example here. This is a fuzzing example for partition, test partition. Okay, the fuzzing engine passes you basically a chunk of data. A set of uint t's, a pointer to a set of USTs, and a length. Okay, that's your fuzzing data. And you, when you write a test for this, a fuzzing entry point, you have to decide how to interpret that. How you're going to take that data and use it to test whatever call you're using. Okay? So what do we do here? We have a vector of un8t data plus size. I create a copy of the data. Then I have this predicate called isEven. It returns true if it takes a number, it returns true if it's even, false if it's not. That's kind of boring. But I partition the vector working B and working 8 according to this partition. That's the call I'm testing. I call std partition. Is this, I'm trying to, partition is a weak version of sort. It basically, you give it a Boolean predicate, and it moves all the ones that satisfy the predicate to the beginning and moves all the ones that don't satisfy to the end. And so the postcondition is, and it returns an iterator. It says right here, here's the first element that doesn't satisfy your predicate. All right, so it did that, and it returned to me an iterator. That's great. I'm happy. How do I test this? How do I say, hey, it didn't crash? OSS fuzz usually runs things with the sanitizers enabled, so if it goes off into Never Never Land, it does wild reads or wild writes. I'll get a report that says this crashed. But let's assume that it didn't crash. Now the question is how is this correct? How do I know this is correct, given random data? So the first thing I say is, okay, all of the items from the beginning of the vector up to this return iterator, up to and not including this iterator, have to satisfy the condition. If they don't, I'm going to return 1. None of the items from iterator to the end should satisfy that condition. If they don't, I return 2. And the last test is permutation. Is the thing that I got out of in working, is this a permutation of the original values I got? When it moved things around, did it add new values? Did I lose some values somewhere? This one was the one who was like, oh yeah, I really need to test that. Not that I expect it to go wrong, but you really need to test it. It'd be a shame if I said, if I got the numbers 1 to 1,000 here, and I said partition these, and it said yes, I can partition these according to all the even numbers first. I'll say 2, 2, 2, 2, 2, 2, 2, 2, 2, followed by 3, 3, 3, 3, 3, 3, 3. That's correctly partitioned, but that's not the values I started with. Anyway, so this is the form of a call that libfuzzer expects. It takes some data, it returns an int. 0 means success. Something other than 0 means failure. And you get reports when A, some input returns failure, B, when some input crashes, which is what the original fuzzers did. They just threw random data at people and saw if it crashed. C, if it takes a long, long time. If it uses excessive, D, if it uses excessive memory. Now, our partition doesn't use any scratch memory, so that's not a problem. But if you give it an arbitrary large amount of data, it could take an arbitrarily long time. It's an order n algorithm, so it's not a constant time, but it's not very slow. At one point, I was getting timeout errors with this code. And the reason was not because partition was taking so long, but because isPermutation was taking a long, long time. That's an n-squared algorithm. So I eventually ended up writing my own version of isPermutation that knew it was dealing with things that could have only 255 possible values. And then suddenly all the timeouts went away. Anyway, so you can see, writing this kind of stuff, there's a little creativity here that you have to decide how to do things, how to test things, and then how you interpret the incoming data to pass to the call you want to test. Sometimes it's easy like this. You just take the data and call the routine. Sort is the same way. But sometimes you have to say, what am I doing here? And then thinking up what the correct thing to test at the end, and then it's just boilerplate. But yeah, this is another case where if people want to get involved with libc++, I encourage them and say, come and learn about some of the algorithms, learn about some of the data structures, and make our testing infrastructure better. Okay, questions? Thought I saw a hand in the back, but nope. Yes.
Thanks for the presentation. You were talking about the assets you are putting to take preconditions, and you say sometimes it's too expensive to do, so we don't put any on it. Could you do something like different level checks for people that are paranoid, or if they want to take bugs, and you say, okay, there's the level 1, which are only cheat checks, and the level 2 are really expensive ones, and you can select the one you want when you want to fight bugs.
Okay, I only got a little of that, but I think you were talking about this test here.
No, I was talking about the macro.
The cert.
Oh, the cert?
Okay.
I have a microphone.
There we go.
Yeah, sorry. I was talking about this macro, and you said sometimes cheap tests are too expensive, so there are O of n square, for instance, in checks. And could we say, okay, there are different level of assets for people who want to find bugs, because sometimes you can have a bug because actually your condition function is not a strict quick ordering, and so people could say, okay, I want to activate tests that are really also expensive, and some like this I can find bugs in my bots and stuff like that. Could that be an option for you or not?
It could be an option. I haven't actually spent any time trying to do that because I didn't think it would be a popular option. There's a lot of stuff going on in the standards group right now. People are talking about this kind of thing in general, talking about contracts and preconditions and postconditions and configurable, how to configure that kind of stuff, versus debug builds versus production builds and so on. And so I've been kind of watching that and trying to think of how I could apply that to libc++, and that means that at the moment I haven't done anything with it.
Okay.
But it's definitely it's definitely been in my mind, even though there's no code to show for it.
Okay, thanks.
Also, libc++ has a debug mode that has sadly languished because there is so much going into the standard library that we've been concentrating on making sure that the library is complete. If I didn't have to sleep, the libc++ would have a better debug mode. There's a bunch of facilities there for debugging iterators and so on that right now are just hooks. It would be better if, there's places where you could check if an iterator came from one container versus another. And I mean, some of the tests, who was in the talk yesterday about the iterator, the static analysis iterator checking. Yeah, I mean, there's some hooks in libc++ to do that kind of things at runtime, but they need a lot of work. And I'm hoping that one of these days I'll get back to those. Other questions?
Yes. Before we take any other questions, is the next speaker already in the room?
Yes. Would you want to come on up and
would you mind getting a microphone from the folks at the back, please? Thank you. Yes, other questions, please.
Hello. So C++ has a memory model.
Yes.
And has functions for threading and atomic. I was wondering, what do you do for testing those?
Not anything great. The question is, what do we do for testing atomic things? And the answer is, mostly we get those from the underlying implementation, and we do very basic tests to make sure that they're sane. Unfortunately, that's a kind of a non-deterministic test. You can start up a couple threads and start banging on them, but if they never actually collide or they never actually race, then your test isn't testing anything. So I don't have a great way to test that. If you have ideas, I'd love to hear them.
We have plenty of time for additional questions if anybody has any more. Yep.
Yep.
So we have experimented with applying the libc++ test suite to another implementation. This is an interesting exercise because it's not. In some cases, you're verifying conformance, and in some cases, you're doing a little bit more white box. Does it behave the way I expected my implementation to behave? Have you considered splitting it up into more strictly conformance versus implementation behavior testing?
Okay, so I don't know if I actually mentioned that when I talked about a test suite. Interestingly enough, yeah, I didn't actually mention it. You want to come on up and plug in? I will unplug. Anyway, yes, other standard library implementations do in fact use the libc++ test suite to verify theirs as well as their additional tests, and you're clearly one of them. So the libc++ test suite is to split up right now into two categories. There's test/std, which is supposed to test things that are defined in the standard, and test/libc++, which are supposed to test things that are specific to libc++'s implementation. And we're not perfect there. But we try to keep everything in STD to be things that are mandated by the standard. We haven't actually gone towards the idea of what you said, white box versus testing implementation details, but we're trying to get there. And if you have specific instances, I'd love to hear about them. Why don't you want to come find me in the hall and we can talk?
Okay. Another thing that I have noticed is there are a few cases where feature A is tested in terms of feature B, and then feature B is tested in terms of feature A.
Okay. We try to avoid that. Clearly, we haven't completely.
Okay. All right. So when I find them, I'll let you know.
Yes, please. Yeah, and I get bug reports on the test suite from other standard library implementers on a regular basis, although usually it's, oh, you're missing this include file or something like that. But sometimes they say, oh, no, this is just wrong, and then we fix them. So I'm quite happy to fix things that make your life easier.
I think we have time for one more quick question. Also, could I ask that if you're sitting in a row with a gap in the middle, could you all please shuffle in, because there's loads of people sitting on the floor. Do we have any last question before we move on to the next talk? Okay, we'll start in a few minutes.
Thank you, everybody.
Let's thank the speaker. Thank you.